scale science. That is to say 5 or 8 or 10 or 20 people, which for them was a radical shift. Alan Thorndike, who ran one of the big bubble chambers at Brookhaven National Laboratory, put it this way: who is the experimenter whose activities we have been discussing? Rarely, if ever, is he a single individual. He may be an organizer of a group of colleagues. He may be a group banded together to carry out the work with no internal hierarchy. He may be a collaboration of individuals or subgroups brought together by a common interest. The experimenter then is not one person, but a composite. He might be 3, more likely 5 or 8, possibly as many as 10 or 20 or more. The experimenter may be spread around geographically, though more often than not, all of him will be at 1 or 2 institutions. He may be ephemeral with a shifting and open-ended membership whose limits are hard to determine. He is a social phenomenon, varied in form and impossible to define precisely. One thing, however, he certainly is not. He is not the traditional image of a cloistered scientist working in isolation at the laboratory bench. The problem, in a sense, that I want to address, if I can, it goes back to Kant, who, speaking about the problem of how we integrate the sensory information that makes an object in general possible, any object, not any particular object, but any object, was arguing against Hume. And Hume believed that this was an empirical process, and Kant said, no, you're not going to get to a notion of the integration of the sensory by integrating objects and things that we perceive, because without the ability to cognize an object in general, we can't even get to the point of that empirical intervention. So he said, Kant said, there can be in us no modes of knowledge, no connection or one mode of, so I would like to get the, can you collapse this?
Yeah.
It's just hard to see that.
Where's your mouse?
Yeah, that's the problem. I want that one right there.
Right. Yeah, but I can't see the mouse.
That's the problem.
Maybe can we just exit for just a second and then I can minimize?
Okay. Now we should be able to
No.
go back to play.
Is that better?
Yep. There can be, says Kant, in us no modes of knowledge, no connection or unity of one mode of knowledge with another, without that unity of consciousness which precedes all data of intuitions. Intuitions are his sense experience, and by relation to which representation of objects is alone possible. This pure, original, unchangeable consciousness I shall name transcendental apperception. Transcendental because it's in back of or prior to the cognition of an object, and apperception because it has to do with this integrative process that is fundamental to, that's presupposed in having the idea of an object at all. Kant goes on to say, it must be possible for the I think, so this is no doubt referring to Descartes, must be possible for the I think to accompany all my representations, for otherwise something would be represented in me which could not be thought at all. And that is equivalent to saying that the representation would be impossible, or at least be nothing to me. If you looked at this plastic barrel and you only saw the parts, but they referred to different parts of my awareness, it wouldn't be anything to me. I wouldn't have an idea of this object at all. So in order to have an idea of an object, of any object, of an object in general, you have to presuppose some kind of integrative function. Okay, so I'm not a Kant scholar. I'm just using this as a launching point as it has served for centuries for what becomes cognitive science and much else in what the process of thinking is about. But the problem that I want to pose is somewhat different. My question is doubly removed from Kant, more prosaic and more dispersed than appending I think to the utterance by an individual. What are the conditions, I want to ask, in which a collaboration can say, we argue, we have shown, the collaboration has shown whatever, the neutrinos have mass, that the Higgs or weak bosons exist, that we have an image of a black hole. What is it for a collaboration ultimately to understand? What do we presuppose in that? So I want to look at this and to make reference here to some interesting work that's been done, although it's different in ways that I can explain. One is by Hutchins about a book called Cognition in the Wild, which is a very interesting study of the deck of a large Navy ship and how they navigate. And it turns out that it's not one person, it's a whole very elaborate set of procedures of different instruments, of the Polaris, of compasses, of gyroscopes, of people sighting things on landmarks when they're near land, of all sorts of things. And they have to be coordinated through a set of procedures and charts, and that he wants to say this requires this group to accomplish this task. Andy Clark pushed this farther in some sense by saying that cognition itself is not something that's contained within head and skull, between skin and skull, because even when you say, I can't do that calculation in my head, and you calculate with long division or more elaborate devices, you're always, you want to say, well, where is the cognition taking place? You end up, he argues, saying that it takes place not just inside the head, but with all these ancillary objects. He's not that interested in the collaboration among people as he is in the use of instruments and auxiliaries to do that. But it already disrupts this idea of thought being entirely located within a single person's head. Okay, this is the BNL 80-inch bubble chamber, just the kind of thing that just one of Thorndike's, the center of his work. And what they produced were these reels of film that then were sent all over the world to different groups, and they'd be analyzed by scanners and then looked at by postdocs and farther along physicists. And then there would be arguments about how things could be demonstrated, but the structure was pretty simple. There was a center and a director and a set of auxiliary institutes that were getting this film. And it was a big political, social issue at the time because there were many universities that couldn't afford or couldn't have $1 million or $10 million bubble chamber. So they had to just be recipients of this film. And then they would be called like the Thorndike group or the Alvarez group or other things. So it was as if a single individual was running and directing this group, and that it bore the name of the director in that sense. It was as if it was an extension of the director. It had a kind of Prussian Germanic structure with a pyramid with one person at the top whose name covered the activities of the group. Now, as you begin to have the electronic instruments with many different subdetectors, things began to change because the production of the instrument itself was dispersed over many institutions, and the way that the group understood the results was often, the muon group would look at the built the muon detector and understood the dynamics of the muon detector, and the calorimeter group was somewhere else, and they built the calorimeter. And so each of these groups, in some sense, had to vouch for the argument of their sector of the instrument. Now, in the 1960s, as you know, Glashow, Sloan, and Weinberg came up with their unified theory of electricity, of electromagnetism, and the weak nuclear force that presupposed the existence of these intermediate vector bosons, the Z0, W plus, and W minus. What was new in their theory at the phenomenological level right away that was clear was that something was possible that was not possible in the older weak interaction theory. Namely, a neutrino, as you see on the left, could bounce off an electron by exchanging this neutral vector boson, making the electron scatter without the neutrino changing into something else. Otherwise, a neutrino, for instance, could change into an electron, and an electron could scatter that way, as you see in the two right Feynman diagrams, or a quark, or so this was this was a new prediction. And so the issue of whether neutral currents existed became very important. The Glashow and Weinberg's theory was 1967. Tufts showed that it was renormalizable, 1971. So in the early 1970s, this became a really pressing issue. Could a neutrino scatter off an electron or quark without changing charge? One of the first of the experiments that was put together, not originally to test this, but then adapted to test it, was the Harvard-Wisconsin Penn Fermilab detector. And one of their worries was, if you looked at, say, a neutrino beam at Fermilab, where they were, it came in from the left and it hit this mixture of calorimeters and spark chambers over here. And there were these counters, there spark chamber 5, spark chamber 6, 7, 8. And one of the worries was that if the neutrino actually produced a muon, so it was not a neutral current, but the muon escaped before it got to this this detector over here, this spark chamber here, that you could be fooled into thinking there were neutral currents when there really weren't. And the senior poobahs on the experiment, Mann, Klein, and Rubia, were not at all convinced that there were weak neutral currents. So they thought that really when neutrinos hit something, they turned into a muon. And so their worry was that the experiment could be completely ordinary, pre-Weinberg-Salam Glashow. Neutrino comes in, makes a muon, but the muon escapes before it gets counted by this spark chamber. And you needed to block all the junk, all the pions and things like that that came out of when a nucleus was hit, because you don't want to get mistakenly think that a pion is a muon. It's a pion, that's just nuclear junk. And so you wanted to be able to filter it out with these big bars of iron, which they had there. So that was their fear, that they were starting to see these events that had no muons, and that they were worried that especially the younger people in the collaboration were going to say they'd found neutral currents, but they hadn't. They were just not seeing the muons that were escaping these at wide angles. That's what that white arrow is supposed to show. So they had an idea. They said, let's put another bar of iron over here where the red arrow is. And then we could use this spark chamber 4 as a muon capturing spark chamber, whereas before only 5 could do that because it had the block of iron there before it. So they put this thin 12-inch bar of iron here, and so they could capture a wide-angle muon like this one that would have missed the spark chamber over here, but now was captured by the spark chamber that's further to the left. It's capturing more of the angle there. So that was the plan. The problem was that because this was only 12 inches thick, some of the pions were punching through. And if they punched through, they'd be counted as a muon, because the iron was supposed to filter out everything that was not a muon. Muons are really good at going through matter. Pions are not. So that became a big dispute in the group, and they argued that there were two different, there was one, they started drafting an article that said basically there are no neutral currents. The ratio of muonless events to events with muons is 0.05 plus or minus 0.05, which is to say compatible with 0. And another, and then they began to, other people began to say there's a muonless signal at the level of 10%. And other people in the collaboration were saying, no, like Sulak were saying there were, 30%. So there was a dispute within the group, and they all started giving talks. They all started going around and saying there are neutral currents, they're not neutral currents, and people began to make fun of them as having discovered alternating neutral currents. They essentially disqualified themselves from winning a Nobel Prize because, as Poincaré once said about Einstein, Einstein had said there, light could be both particulate and wave-like, and he said from a contradiction anything will follow. And so if you say X and not X, you've claimed exactly 0, nothing. So this is what happens when you have a group that splits into parts and begins saying contradictory things in public. This became one of the nightmares. This is not the first time, but it was a very salient moment because the stakes were so high. This would have been the first confirmation of weak neutral currents, and therefore the first really distinctive demonstration that the Weinberg-Salam-Glashow unified field theory was on the right track, and it would have been, along with the renormalization of electroweak theory, an enormously important event. Another example, more 20 years later, was at the Los Alamos Meson facility, where the collaboration published that neutrinos had a mass, namely that there were some oscillation between anti-muon neutrinos and anti-electron neutrinos. But one of the members of the collaboration, a UPenn grad student named James Hill, disagreed, and he thought their candidate events were not good. In fact, only 2 of them were even plausible, which made it statistically dubious. And then the issue became, so he dissented. But then who signs these papers, and what is the obligation of Phys-Rev letters to the 2 different groups? Anyway, Phys-Rev letters decided to publish them both back to back in 1995, one saying there is oscillation and the other saying there's not neutrino oscillation. And this really upset the high energy experimentalists in the community, and some of them, like Roy Schwitter, said, oh, absolutely, we need to have freedom of speech. People need to be able to speak their minds and say, what they're discovering. They can't have this authoritarian structure that's going to squelch their views. And others said, this is threatening the coherence of the collaboration. So this is what I mean by the problem of a loss of the coherence of the group, but also the temptations of not imposing coherence on the group. It's not a simple matter in how you handle and control these questions. So the analog to Kant, in some sense, in this world, is of a big collaboration, is how do these different interpretations and moves within the experiment get integrated? How does the collaboration come up with a narrative line, a claim, an argument that they stick behind, and how much conformity is required, who controls who can speak, all of these little mechanisms become central to the literal authority of the authoredness of the collaborative result.
So what happened on that? I mean, I assume that since we don't have a mass of the neutrino that will ultimately indicate.
No, other way around. We do think that neutrinos can have a mass.
But the Galison decollaboration got it wrong.
Right.
The oscillations they were seeing turned out to be statistical analysis.
Right.
But mini beam confirmed other
Later on.
Later.
Okay.
So actually, the
Oh, I see.
writing was right.
Okay.
Yeah.
I like that. Okay.
There's no symmetry protecting the masslessness of neutrinos. So, but the collaborations began to grow. The SLAC Large Detector in July of 1988, wrote a piece called "Who is an Author," which sounds like Michel Foucault, but this is coming from the heartland of particle physics. By then, the collaborations were not 5 or 8 or 20, they were hundreds. Our first priority, they said, should be the coherence of the group and the de facto recognition that contributions to a piece of physics are made by all collaborators in different ways. So there's a whole cluster of issues that all converged here. What about free speech? What about credit? How do you assign credit in a big collaboration? How do you have, who counts as an author? Are engineers authors? So some of the collaboration said engineers will co-author the first paper, but not subsequent papers. Other groups said there's a difference between the planned papers and sort of spontaneously generated papers along the way that weren't part of the original proposal. There's the authority of the collaboration to speak, and whether the weight of the collaboration is behind a result. Opal in 1997, the omnipurpose apparatus at LEP, at the Large Electron Positron Collider at CERN, had 200 members, and they instituted this system of internal review. which became, this kind of thing became popular in all of these collaborations, where the collaborations, in a sense, were acting like small or not so small scientific communities where they had internal refereeing and internal publication, authority and working memos and, rules for who could author them and what could be published and so on. Opal operates a rigorous internal review procedure for all physics results, which are to be published or shown outside Opal, whether final or preliminary. The aim is to ensure that Opal results are reliable, of high quality, and well presented. Results should never be discussed outside the collaboration before members of Opal have had an adequate chance to examine, criticize, and approve them. And the collaborations kept getting bigger. D0 at Fermilab, which ran until 2011, had 380. As you get these colliding beam apparatus, you have these different layers, in crude terms, sort of concentric cylinders, each of which measures something else. Calorimeters, muon detectors, central tracking devices, and much else. So the D0 had these rules of authorship. And they started by saying, if you want to be an author on a D0, some of the collaborations would say things like, if you want to be an author, you have to take data. Well, some people said, oh, taking data, that's not what I do. I write Monte Carlo simulations. And they said, okay, you can take data or do Monte Carlo simulations. And they said, oh, wait a second, I'm a phenomenologist. Without me, you're not going to know how to interpret your results at all. Not sort of high level quantum field theory, but just what the phenomenology of the experiment was. Okay, you can be a theorist. And then what about, I'm organizing all the working groups, or I'm the director, or I'm the associate director. And as these collaborations got bigger, the number of tasks multiplied. And then, so there's a list, I'm just taking the first 7, design, construct, or debug the detector. So, and then the question is, so if you designed, debugged, or constructed the detector, are you an author of all papers forever? For the entire thing, or how long can you be a member before you? How long do you have to be a member before you count as an author? Or if you join, can you immediately become an author on the papers that are about to come out? So there were the reciprocal problems. Write software, Monte Carlos, utility programs, cleaning up the data, process Monte Carlos or real data, run shifts at the test facility, manage personnel issues, be a convener of one of the working groups, write or review D0 papers, advise students, take part in meetings, workshops, analyze physics. You can see it begins to expand because these are huge, and that doesn't even start with all the engineering processes. For instance, in a certain sense, the Nobel Prize serves to squelch the recognition of collaborative work because it wants to pick out 1 or 2 or 3 people. In fact, all the prize structures, but also promotion and hiring, it wants to pick out individuals for their contribution, but there's also all of this collective work. And there can be particular glory in being the person who does the final analysis and calculates the mass of the Higgs, but that may not be a very difficult, but that may be a completely routine problem for the people that have been working on this for 10 or 15 years, building this billion-dollar detector. So there's
how long is this?
I don't remember, but much longer than this. And necessarily incomplete. So the D0 reviewed the process for publication. They had said there's an editorial board, which consists of the author plus 4 other physicists, a godparent, someone from the same group.
Peter, I'm sorry, when you say the author, you've already raised enough questions about who an author is. What do you mean the author?
Well, so you have a paper that you want to propose to publish, and you put it forward, or you and your 10 best friends, or this hasn't even determined what the final list of authors will be, but somebody's presenting, and someone from the group that's done this analysis. So presumably, like on the, the Higgs, it wasn't the original discovery paper, but all of the other papers that came out of that. A godparent who's someone from the same group, and 2 other collaboration members, not in the authorial group of the proposed paper. And that this group then has, this editorial board has all the backup material, not just the paper. They get access to the, whatever raw data is being used, whatever subroutine that software that's being used for the analysis, everything. One copy of the proposed publication goes to the editorial board and one to the whole collaboration. The D0 then puts author on the board to, quote, avoid confrontations. So they had some bad experiences where, the editorial board is saying, no, you haven't shown this. Yeah, we have. And so they incorporated that in. I give you these details just to give you an idea how complicated this negotiation has been. After a waiting period of 4, respectively 10 days, there's an electronic posting followed by a public reading. I picture sort of the Monty Python reading of the scroll comes out, so there's a public reading. This is pre-Zoom, so, the LHC Atlas group then grew to 2,500 people. CMS has about 2,500 people. That means 5,000. The size of the worldwide high energy experimental community is probably 10, 12,000 people. So this is a big, this isn't going to go on forever, right? This has reached its natural limit. If you have a colliding beam and the beams hit in 2 different places and half of the community is involved in this, you're not going to be 25,000 people. There aren't 25,000 experimental high energy physicists. So, and they introduced the idea of a scientific note, which could be a kind of internal publication, not for public disclosure, but which served to help give credit for early career or people who've done particular work in a certain way. But it was always a balance. And then there were restrictions on what could go into an internal note and what couldn't. Because the idea of giving people credit for their particular work often clashed with the idea of shared credit for all the people that did the work that made this possible. You don't want to just give credit to the person that puts the bow on the carefully constructed wooden boat. You want to give people credit for all that work along the way. So this became a part. So these ideas of this conflict between free speech and epistemic authority runs deep. It tries to recognize the prerogatives of individuals while preserving the coherence of the group. And the terror of alternating neutral currents or the divided publications at the Los Alamos Mason facility hung in the air for everybody. And there are lots of other examples. I choose these 2 because they were so directly clashing right at the same time about saying X and not X. So who gets to speak? And related to that, who takes responsibility for the publication? Who says, we've shown this, we stand behind this result? How much of that, especially as these, you get to billion-dollar detectors, no individual knows all of the workings of all of these different detector parts and all of the different programs and their quirks and foibles. And the hardest question of all is who understands the result? What does it mean? What is understanding for a collaboration? You can black box certain procedures, you do tests and you say, okay, I may not know exactly how this calorimeter works, but I can send in a test beam and I can see that it's responding properly to inputs. Does that tell you that you know all of its failure modes? No, but it gives, at a certain point you say, I have an adequate and to the day understanding. So that then will bring us next time to the Event Horizon Telescope, which, unlike the high energy physics community, even as dispersed as they get in some of these very large collaborations like the Large Hadron Collider, the CMS and Atlas, CERN still does have a center. There's a paneled office and an extremely highly paid director general of CERN. There is an authority and a site and a budget and money that flows through it from the European Union out to the various constituent laboratories. Through resources, coordination, the detector is in a place, it's located on this ring. And all of these things, no matter how dispersed the analysis gets, and it's very dispersed, isn't as dispersed as the EHT, which not only is located in its antennas all over the place, but the groups are much more dispersed even than that. And since money does not come from a central source, and each of these groups is, and the telescopes are, each of these telescopes is probably order $1 billion. So they're not paid for by the Event Horizon Telescope. They're competing for time on these telescopes, and then all of these groups are in different cultures, different scientific cultures, different broader cultures, trying to coordinate. It means that there's a level of dispersion in the EHT that is different, which makes the problem of coordination and coming to a collaboration assent to saying, okay, we believe this picture is justified, is not an artifact, or this parameter, the mass over distance, is, we believe it within the error bars that we've said. These are all things that are even harder in some way, even though the experiment itself is only 350 people. I don't know how big is the HT now? Do you know? Yeah. And so there's been this elaboration of different sorts of reviews of focus groups that constitute working groups, and the working groups, part of the collaboration. Collaboration has postings of meetings of, obviously the Zoom and its antecedent forms play a very important role, because people, even in these focus groups, are not just focus groups at an institution. They're over many. There's a publication committee. What the authority of the publication committee is not always been clear. The different kinds of publication, official papers, collaboration papers, unrelated papers, related papers. There are all sorts of different categories. There's an internal refereeing process, external refereeing process. So there's a very elaborate set of these procedures, which in some ways carry even more importance because of the broader, more dispersed nature of the collaboration. So what I want to do next time is to talk about the epistemology of getting an argument through a collaboration in this dispersed mode. The fears of fragmentation, which are not dissimilar from the ones that high energy physics has faced, that if you say X and not X, you're saying nothing, of how to treat variable objects. If you have the pictures of, on different nights, as the HT did in 2019, how do you integrate them? How do you relate them to one another? What do you consider to be variation of the objects over time on different days and within an observation? The longer history of getting an objective image of something in natural science has different components, and I'll talk about that, of trying to get a very mechanical, sort of parametric, systematized understanding of the image, of using expert judgment, of trying to get an ideal image by combining these other images in various ways of weighted averaging or averaging, and of how to handle questions of individual sub-collaboration or methodological bias. Of different imaging programs have different vulnerabilities and different strengths, and different groups have different predilections about what the truth of the matter is, and how these are integrated will be the subject of the next talk. So I'm now ending.
There's a chat that has been hanging out for a while.
I can take them. You can remind me if I'm missing.
We'll be on the lookout for hands.
Okay, Jeremy's comment, very nice. Thank you, Jeremy, if you're still there. And I'll just go Priya, and then Eric, Richard, and Shep, Andy, Ramesh. We have time for discussion.
Yeah.
So very, very interesting and really nice framing here to understand these issues. So I kind of, so do you think these are, do you think that the sort of the collaborative enterprise did something to disrupt the trope of the lone scientific genius. But on the other hand, it seems to be, sort of, has a new avatar, right? Because a collaboration there's authorities again vested amongst a small number of people. And the data is not openly shared. So for example, so I'm just wondering how in the sort of frame of what we believe science to be, how did collaboration really make such a big dent? How come they were not attacked and saying, look, you're not sharing the data openly. Independent analyses have not been done by others. And so why should we believe? So this trust, how this trust got vested. So very interested in your thoughts on that process.
So I think in some ways, collaboration at this scale makes plain something that's true for science more generally, right? But it's harder to maintain the fiction that it's only an individual who produced the Higgs. But there are recuperative efforts to do that, and that's what prize committees do, right? They try to say the leaders, are these one or two or three people. Some prize committees have said, okay, let's recognize a collaboration, or let's recognize an individual or two or three plus a collaboration. I don't think that I really don't think we've absorbed the nature of collaboration very well. The reality of work in groups is hard. Now, and this is true in theory, and Andy's often collaborated with others, and it's not so easy to say, in a discussion, a 3-hour discussion about something, you're writing things down, like whose idea is which, even in the case of a relatively small collaboration. In theory and in experiment, it's much wider, and you have this other feature of all the engineering that goes into it. Where are the boundaries of an experiment? It's very hard to set, and as these big apparatus are constructed industrially more and more, do you give authorial credit to Intel? Where are the limits of what counts as the experiment? It becomes complicated. And we don't want to give up the recognition of individuals' contributions. And we want to be able to allow each new generation to rise. People do have to hire X and not Y. And those decisions still have to be made. So I think there are forces that are competing here. I don't have a view that there's like one magic solution. As far as sharing data goes, there have been examples, including recently, where a collaboration will share data and someone else who's got their routine already outside the collaboration, like in the first minute, publishes some result as soon as the data is out. And that's caused a lot of friction for people that have just spent 10 years working on this experiment to not have had a chance to actually sort of harvest the fruits of their labor. So but there are general consensus views. In astrophysics, ALMA has a policy about how long you can hold data before disclosing it. So there's these are all balances between sequestering data and allowing people to exploit
But I think
them.
sometimes, I think the Dama Libra claim of having detected black matter and the multiple replications that eventually happened that have demonstrated that it was not a result. Have been an interesting case.
Yes. And when these
Exactly.
experiments are so expensive, no one's going to replicate CMS, right? No one's going to do that again.
So I think that part of what's behind what you're saying is that criminal results are not autobiographical reports. They're statements of socially affirmable facts. And we started with Hutchins and Clark, and what is cognition? I'm curious. The way that you present the paper at the Hutchins, it seems to suggest that part of how we get at that is by looking at issues like authorship and the results of internal deliberation that are constrained by internal regulations. That leaves me kind of unsatisfied. Are there other ways of getting at what epistemic
Yes, and I'm going to turn to that next time. I would to look in detail at how One of the bits of raw data that I have for making the film is extensive filming of discussions that didn't make it into the film. So I'm going to take an example of the deliberation over, for example, how to make a canonical image, a reference image for M87, as we talk about that in more detail. Richard?
So I think fragmentation has a negative connotation, but it really often hides the important need for dialectic. And dialectic is often a healthy back and forth that helps get away from some of the consequences of groupthink and consensus. And I think there's another issue with apparently conflicting messages really stemming from information loss from giving a tidbit that you can share with the public rather than actually going through the details required to come to a conclusion. Because if you were to have the authors of the no recurrence paper and the authors of the recurrence paper just switch and do each other's experiments and do each other's calculations, you can imagine that they would likely come to the same conclusions. And it's because we're not in the position as communicators of science to spell out every detail. That's why we just come up with these like 50 labels of recurrent versus no recurrent. And it's not really embracing the complexity that's inherently what they've done. So I think that a lot of the issues that are with these scientific messaging appearing to conflict very adequate comes with the lack of appreciation for the inherent complexity of the issues and the tendency to quickly tell people to, oh, what would a fifth grader what message would get to a fifth grader rather than actually embracing the fact that these things are often complicated enough that you're going to hide a lot of apparent contradictions without it.
I mean, it's a very good point. I mean, Roy Schwitters, who was the head of the Once and Never Superconducting Super Collider, came out strongly in favor of publishing conflicting reports. I mean, you could see, there's a model that you could support. I mean, it's not incoherent to say what happened in the weak neutral currents argument is actually a good thing, and that that having that dispute in public is just science, and that eventually the group did come to a consensus, and all of them, Ruby, Man, Klein, the whole group of them agreed, and they published a paper saying there were neutral currents, and they're at this percentage, of the total number of neutrino interactions, and it also was consistent with what they were seeing at CERN, where the Gargamel bubble chamber, heavy liquid bubble chamber, also had an internal dispute and also split into the more experienced bubble chamber experts who came into the experiment thinking that you couldn't have weak neutral currents, and then this other group like Puglia and Paul Musset and others who said there were. So you could say what we're seeing in this public version of these disputes when they do leak out is just the way science should run. And but the downside is also, the downside is that the exterior world will say this collaboration doesn't know what they're talking about. They've actually, they can't even agree on what they've seen. So why should we believe them?
Which is why we should maybe get rid of the spin stuff and say, okay, these results actually complex and that's the reason actually.
Chat.
And this is ultimately what happened in the Event Horizon Telescope in some areas. And it's good to get all of your dissension out in the open within the collaboration, and then decide formally how to move forward after that. But there need to be standards. You need to ask yourself, what internally do we need to do to feel comfortable to present a unified result? And then what happens if we don't have that? So I'll be interested to hear more about what people think about that.
I mean, I think that's true. To me, what epistemology ultimately is always, or epistemology at a given time, because I think it changes, is a response to a fear. Like if there's some worry that you have, and the worries can be different. The worry for, in the 18th century or 17th century was that you would be fooled by the varieties of things that one sees in nature. And what the response to that was to idealize and to abstract from the particular plant that was growing outside your window and not get fooled by the variation of one skull to another skull, and begin to think about the truth about skulls was something to be abstracted and idealized. That's very, or statistical arguments. I mean, people didn't put error bars in experimental papers until the 20th century. It was like that's not true for astronomy, where it goes back farther. But in most of physics, it really isn't until the 1920s, 10s and 20s that you begin to see error bars. So epistemology in science, the standards of how you demonstrate the acquisition and securing of knowledge, does change. And I think that one of the things that happens in a collaboration is trying to figure out what those standards are. What will make something rise to the point where the collaboration feels secure enough in that knowledge to be able to release it? One response would be, you shouldn't be so worried about that. I mean, essentially, Richard is saying that. He said you should have that discussion in public, not in private. And well, but that's those are two sides. And the reason that the Los Alamos example is important is not because the experiment is particularly important, but everybody weighed in on it. It was a real, what's the responsibility of the journal to the collaboration? Do they, is it fair for the journal to publish what this graduate student was saying, or some other subgroup, and to give it equal weight by publishing them back to back? But if they don't do that, then are they acting in cahoots with the collaboration leadership? So as I say, I think that the issue will be, and I'll talk about this, the different fears that arose at different stages of the Event Horizon Telescope work up to 2019 about what a demonstration, what would be adequate unto the day, and then what should be released. Do we owe it? Did the collaboration owe it to the scientific and broader public to have one image, or we could have published 20 images, and they were all somewhat different from one another? There were arguments about that, and I think interesting ones. So I think these are ultimately the epistemological questions that arise in big collaborations in very interesting ways. Ramesh.
Yeah, same issues. Extremely interesting, and obviously there's no clear answer. And I'm thinking of climate change, where you can have a consensus, but you can have the few outliers and it causes a lot of trouble. So I was just wondering, let's take Atlas. They had 2,500 authors in the collaboration, and they published papers. They are publishing lots of papers. At the same time, I do not believe that every one of the 2,500 completely signs on to the results. I'm sure there are some dissenters. So my question is, what do they do? The dissenters are not publishing their separate papers, as far as I can tell. I'm not following the literature.
Right.
So what is the internal mechanism that they are following? I'm not saying it doesn't have to be the right thing, but what exactly do they do, these collaborations?
Well, I think so to cut to the chase, I think there are people who end up in big collaboration who are not happy with the result. Okay, but there are a whole series of mechanisms along the way where that are supposed to give a site for giving voice to your objections, to make the case. for whether it's in, I'm using EHT vocabulary, I don't remember what it is but a focus group or the working group and so on. So there are different forums up to the collaboration meetings and so on where people hash it out and they'll make a case for why they don't believe that the result is strong or that the statistical weight has been exaggerated or that they haven't taken seriously a counter result that was observed. And so what people do is to try to make their case along the way.
Yeah, but that's all internal.
It's internal.
But the person is not allowed to publish
That's right.
separately. But this is where, what's the right of free speech and right of dissent and what's all that? I mean, so.
Yes.
Maybe next time you're going to tell us.
Well, I'm not going to solve that problem, but I mean, I've said this as free speech and epistemic authority because I labeled that because I think this is a real tension. And, it's a disanalogy between, I said that there's certain aspects of the big collaboration that resemble the scientific community as a whole. Internal refereeing, internal publication, and there are lots of mechanisms that look and sound like what the community does. It's not physical letters, it's a working, note or what's called different things in different collaborations. But one respect that is different is that in the broader community, it is possible to get a broader range of things published than there is inside a collaboration. And Atlas does have, or the EHT has, a publication committee that is that adjudicate whether this can be published. And unlike the bigger publication committees, they don't want to issue contradictory. I mean, on the whole, they don't issue contradictory authorization for contradictory claims. So I think the issue of this is a balance. I mean, Shep was saying it's important to have some kind of coherent presentations to the outside. Richard and you were both pointing out the immense value of being able to say, I disagree. I mean, there are people who don't want to join collaborations precisely because they want to be able to have that freedom of action. It comes at a cost of not having access to the data over a period of many years. I mean, so it's
resources.
And resources, right? I mean, it's and being part of a community. I'm not. This talk isn't a resolution to authority and dissent, but that's a political question that we've been talking about for 2,500 years. But it's I think that in one of the debates that took place is how the authority structure in these big experiments works. Some people wanted to have each institution represented by a person or two and onto the board as sort of a House of Representatives model or a senatorial model. Other ones wanted to have people chosen on the base, like a kind of cabinet, and each of these has failings. But when you have a collectivity of 100 or 1,000 or 2,500 people, these questions that might seem like social questions are actually also questions about scientific reasoning. Andy.
Yeah, so I guess that was all very stimulating to think or interesting to think about. You're talking about the process in this case of where you start out, you have some particle collisions, which are measured somehow. You're talking about the process by which those particle collisions are interpreted, and somehow, some amount of time later, there's a public perception, both of what it means and who did it. And it seems to me that in that process, or could you comment on, in that process, this business of exactly how the collaboration is structured, who is on the papers, what the rules are, and so on, is not an insignificant, but it's not the controlling factor, right? There are many other things that happen, right? Certain people in the press appear on TV. Certain people in the collaboration will appear on TV. Some people get invited to give more seminars. Some people talk in a more credible way. And then even after it's all done and all the papers are written, history gets rewritten, as you know, sometimes in rather fantastic ways. And in this example of the two papers, that argument was surely, I don't really remember it specifically, but surely it was leaked before it was, and it was decided in the community who was right, who was wrong, or depending, and the actual publication, what the publications were actually a small perturbation in this larger, and it seems to me, uncontrollable process. There's so many random factors. This uncontrollable process of the information from the actual experiment getting out and being attributed to certain people. It's the one thing that we might have some hope to control it, but even if we came up with a perfect resolution about what fair collaboration rules were, it still, I think, would have a rather small effect on this
Well, I think,
larger issue of
Yeah.
getting from experiments to public perception of what the truth about the universe is that comes from that, and
yes.
who found it.
Well, I think that you've made several important points. I think that how results are presented, and it's not just the public, it's the rest of the scientific community, matters a lot.
Right.
And there are some people who are very good scientists who don't want or aren't good at that, and other people who might be good scientists and good at that, and people who are not good scientists but are good at the sort of managing their public relations. So all of those possibilities exist. And we've seen examples of all of them. I think that the question of leaking, whatever else is true of the HT, it kept its picture pretty secret for all that time, almost not 9 or 10 months without anybody publishing. There was one near miss, but
Right, but I don't think anybody in this room will say that the attribution of credit for that picture was, I was not, that somehow was done in a logical way.
right. Yeah, no, the credit question is is very real and affects people at every role and stage. But the question of leaking, I think, is separate from that. And the
Right.
HT did not leak. In fact, up until the end, the press was saying it was going to be about Sagittarius A star. It wasn't.
Right.
So it's
That
like
is
they didn't
true.
even they
That is
weren't
true.
even in the right part of the sky.
That is true, yeah.
That was in some ways that was the most amazing thing that didn't that nobody.
Yeah. And
I
of
mean,
course,
academics-
you can't have a situation where somebody raises millions and billions of dollars and they do an experiment, and then if everything's open, they do an experiment, somebody grabs the data, analyzes it.
Well, that happened. That happens. And
That
there are
happens,
examples of that where, it comes back to Priya's, first question, which is, openness. There's a big discussion going on at many universities, including at MIT, where it's quite vigorously underway, where should graduate students' theses be immediately put up on the web? And in certain fields, they've already published the papers, so it doesn't matter. But in other fields, you get somebody who's been working on a study of the Trobriand Islanders for 10 years or 8 years, and then they publish up, and somebody scoops up their main results, includes it in their book, and then when the young anthropologist wants to publish, the publisher says, well, why should we publish this? Senior person Q has already published this. Even if they footnoted you, it's like you're not going to get a job on the basis of a footnote. So I think that and I think there's something similar writ large in the collaboration, like you work for so long on it and publishing it, publishing the data, which, people have spent thousands and thousands of hours making sure that the data is consistent and clean of artifacts and so on. And then somebody else comes in and just runs a routine on it. That doesn't seem fair. On the other hand, the idea of permanent secrecy for data also seems unfair. So there's there's a struggle over this. Oh, it's 11 o'clock and I promised. Okay, thank you.
This is the way it should be done, Peter.
Yeah.
This is the way it should be done, yeah. Enough time for discussion. Question. We still ran out of time, but this is good.